Yeah, I wasn't able to try out both mics. I mean, I guess I could have and returned whatever I didn't like, but I just got this one. Alright, so if you guys weren't already in the Zoom meeting, let me share my screen. If I go to the home page for our course, I added, let me go to student view. Okay, so if you're on the home page for the course, I added all the lecture slides that we're going to have for chapter 1. So just go to files on the left hand side, then go to lectures, and then you can download all of the slides that I have for chapter 1. Or if you're on the home page, you can go to today's page, and then they're available right there too. And then so I have the schedule for today. I don't know if we're going to get to all of this, but this is what we have, and then also for on Wednesday as well. So first we're going to go over some review for what we did last week, just to kind of refresh yourself. Then we'll go over some of the MATLAB functions that we have, some really basic ones. We'll talk about complex numbers, and then we're going to go over a really brief intro to arrays. And I'm guessing that's where we're going to stop, but who knows. If we have time, we'll go over the length command and the numel command as well. And I guess if we really have time, we can go over this stuff too, but I doubt we'll get to that. Alright, also, I uploaded the lecture from last class, so if you're on the home page and you go to the page for the first week, click on that. And then you see here that I have the link for the lecture, for the video. I remember for the first class, my computer that I'm currently using to record the Zoom session, it froze, so I couldn't recover that recording. But we didn't go over anything that was too important there. Okay. Question, is there going to be any homework for today? I won't assign homework today, but I'll assign it on Wednesday, and then I'll give you a full week to work on that. So I'll assign it on Wednesday, and it'll be due next Wednesday by 11:59 p.m.
Patrick, so I'm just a little recap on Wednesday. We didn't do much, right?
Last Wednesday, no, just some really basic stuff for MATLAB.
Basic stuff. Okay,
Yeah.
I see. Cause I feel a bit lost in MATLAB, like in terms of how we do this and stuff.
Yeah, we're gonna go over some review right now before we
Okay.
do new stuff.
Okay. But today we are gonna do some MATLAB, right?
Yeah, we're gonna use MATLAB the entire time.
All right.
Yeah, so open up MATLAB if you guys haven't already, and then we're gonna first do review and then we'll do some new stuff. Okay, so last time we went over the command window. Basically, we went over the layout for how MATLAB looks. We talked about comments and why we use comments. And then we did some really basic math operations. Talked about precedence, really, it was PEMDAS, instead of MATLAB. And then we went over some formatting options for how we can display text or numbers inside of MATLAB. Moving my video to the bottom. Okay. So when you first open up MATLAB, it should look like this. So your editor window should be here, and command windows on the bottom. For us, we can close out of the editor window because we're not going to use that quite yet. We'll probably start using that either next week or the week after. So that's to make a script, but we're not going to make any scripts quite yet. So we're in the command window here. This is the main window in the center. The workspace is on the right hand side, so remember this is where we store our variables. So if I go back to the command window and I type in, or I assign a value of 5 to the variable x, and I press enter, then it shows up in the workspace on the right hand side. So we see our variable x, and then that has a value of 5. And if we want to suppress the output, so if we want to assign a variable but we don't want to see it kind of repeat what we just assigned, we can use a semicolon. So if I do y equals 100 and I put a semicolon and then I press enter, it's not going to show up again in the command window, but it is stored inside of MATLAB. So you see it's over here in the workspace, this new variable y, it was assigned a value of 100. Right, and then we talked about comments. So remember, a comment in MATLAB, that is first started by using a %sign. So if I put in a %sign, I can say this is a comment, and if I press enter, nothing actually happens inside of MATLAB. MATLAB doesn't run this line of code in a way where it would store anything inside of the workspace. This comment is just for us, for readability, mostly once we start writing a script. So MATLAB will basically ignore this line of code because I have a %sign. There's also like a little modification, so I can do something like high equals 10, why not? So I can assign a value of 10 to this variable called high, and after this I can put a comment if I want. So I'm assigning a variable, or I guess a value. So in this case, MATLAB will run high equals 10, so this variable high that will show up in the workspace, it'll have a value of 10, but this comment at the end here won't be registered by MATLAB, so everything right here that I have highlighted will be ignored by MATLAB. So if I press enter, then you see in the workspace, high, that's the variable, that was assigned a value of 10. Okay, any questions so far for the review? How do we get...
yeah, what is percentage again?
The percentage is to make a comment inside of MATLAB.
Oh, to make a comment, okay.
Okay, so a semicolon, that's to suppress output. So if let's clear this first. So let's do, I don't know, z equals 20. So if I don't put a semicolon and I press enter, then z equals 20 shows up again right below this line. If I do y equals 30 and I put a semicolon and then I press enter, that doesn't reappear right below that first line that I just inputted right here. But that variable is still assigned and it's stored in the workspace. Does that answer your question? Okay. And then how do we get get out of dark mode again? So if you want to get out of dark mode, you can go to preferences up top here. And then go to colors, this tab here. And then you'll see an option in the bottom right hand corner to restore default colors. And then also last time when I was, if you do 2% signs, you can get what's called a section. And last time it was like black, and I forgot how to change it. To change it, you just need to go to then programming tools and then highlight sections. And by default, it's this like kind of yellow color. Okay, so let's do some basic math operations that we talked about last time. So it's very basic. Also, I should show you those commands too. Oops, I'm going to do x equals 50. So to clear all of the text in the command window, but preserve the variables over here in the workspace, I can type in CLC. So typing in CLC, that's going to clear all of this text here. So I'll press enter. It's all cleared in the command window, but in the workspace, our variable is still stored there. If I want to clear that as well, I can type in the word clear and then press enter, and then that goes away. Okay, so we'll do some basic math, exercises. So let's put a comment, just so we can use a comment, and let's do addition. So let's do x equals 5 plus 3. 5 plus 3, I'll put a semicolon, then I'll press enter. And then you see in the workspace, x is assigned a value of 8. Because MATLAB, it assigned or made this variable x, and it assigned a value of 5 plus 3. So MATLAB did this math operation itself. So added 5 plus 3, that's 8. So we get our variable x is equal to 8. Subtraction works as you would expect, so just 6 minus 3, that'll be 3. Remember MATLAB, if we don't assign a variable ourselves explicitly, MATLAB will assign a variable of ANS for answer by default. Let's do some multiplication now, so let's do x times 2. So x has a value of 8, MATLAB knows that, and if we multiply it by 2, well, we should get an answer of 16. And MATLAB will also overwrite this variable a and s here from 3 to 16. So let's press enter, and then you see we get a and s equals 16, and that shows up in the workspace. Any questions on that? Okay, and then we'll do division just to kind of recap that too. Let's do z equals 9 divided by 3. So for normal division that we use every day, that's going to be a forward slash inside of MATLAB. So z equals 9 divided by 3. That'll be 3. And because I didn't put a semicolon, I should see right below here when I press enter, z equals 3. And that's what we get. And then in the workspace, that's updated as well. Okay, so precedence, I'm going to have an exercise for this actually right now. So we're going to do that in a second. So remember, for precedence with these map operations, it's really just PEMDAS like you learned in, elementary school or whatever. When we're doing parentheses first, that has the highest, precedence. And then we have exponentiation, then multiplication and division from the left to right, so whichever occurs first. And then we have addition and subtraction from left to right, whichever occurs first. Formatting options, we had a slide on that, so let me go to that really quick. It's kind of small here, but these are all the options that we have. So we can change our sig figs if we want, or I should really just say the amount of digits that we have. So we can have 4 decimal digits, so 4 digits after the decimal point, or we can have 16, or we have these other options here. So, and we can also have a fraction. So this is going to be part of the exercise that you're about to do. So by default, you're probably not going to have a fraction. So if I do like 16 divided by, 5, then I get an answer in decimal form of 3.2. But if I want to make this in a fraction, I can do format and then rat, which stands for rational. I can press enter. And then what I just did, right, remember I can press up on my keyboard to access previous lines of code that I typed in. So if I press up on my keyboard and I do it one more time, I can go to the line of code when I did 16 divided by 5. Now I can press enter. And because I put in format rat before, our answer now for 16 divided by 5 is left in a fraction format. Okay, so I'm going to go back to what I usually have, which is short G's at capital G. I kind of forget off the top of my head. Yeah. And then I have it in this kind of format. So we could also have it, with 4 digits after the decimal point. I don't care how you have this format, it's up to you. But yeah, that's how you can change the format. Okay, so any questions before we get started on your exercise?
So why did you put form rat form short G?
I was changing the format instead of being in a rational format, so it's like a fraction here. If you type in short G, it'll be in a decimal format and basically as short as it can be. So here we only needed 1 digit after the decimal point.
Okay.
Okay. So yeah, week 1 review, we went over that. Week 2 schedule, we went over that. I put this on Canvas basically. And now you guys can work on this exercise here. I'll make this bigger. So I want you to define a equals 4 and b equals -20 in the command window. So you're going to make those variables and assign them 4 and -20. And then you're going to work on doing this line of code. So you're going to do z equals a divided by b plus 5 times 10 squared. And also change the formatting so it can be in a fraction. So remember that was format rat. And you should get an answer of -80 divided by 30. So I'll give you like a minute to work on this, or a minute or two, and then we'll go over how to do it. So make sure your parentheses are set up correctly, like the denominator here, and then you should be good. Alright, so I'll give you a few minutes. Okay. Is everyone done? You can just put it in the chat. Usually I use a poll, but I didn't make one. Okay. Alright, so if you're not done, that's okay. We'll go over it as a class right now. So what I'll first do, I'm going to clear the command window. So I'm going to type in CLC. Done in all caps, nice. Okay, so first off, I'm going to define a equals 4 and b equals negative 20. So I can do a equals 4, and I'll put a semicolon so I can suppress the output. I don't need to see that. So I can press enter, and then it'll show up in the workspace. I can also do a equals 4, and on the same line, I can assign b equals negative 20. So just to kind of like, save space, I'm going to put a equals 4 and b equals negative 20 on the same line. And now if I press enter, both of them show up in the workspace. Okay, and then I'll do, the actual problem here is that z equals a, so that's in the numerator, then divided by b plus 5. So b plus 5, that's our denominator. I put that in parentheses because we have two terms in the denominator. And then we're going to multiply this by 10 squared. Okay, so we'll press enter. Right now it's going to be in decimal form because that's the last formatting that I assigned. So I can do format rat, and then I can also put in z here. So this will change our formatting to a rational expression. And I terminated this, so I put a semicolon. And then I put in z. So I'm telling MATLAB to change the formatting to a fraction, and then to display the output for the variable z that we just made. So press enter, and then we get negative 80 divided by 3. Alright, so if you want to be explicit with how the problem is set up, you could have also done something like this, where we have the term on the left-hand side, so a divided by b plus 5. You could have wrapped that all in parentheses, but that doesn't, it's not necessary. You don't have to do this, and, if you really want to get technical, you're using more memory than you have to, but it's insignificant. The amount of memory for these parentheses is, minuscule. So for me, I don't really care too much if you use parentheses. I'm not going to mark you down if you use more than you have to. It doesn't matter. Whatever kind of works best for your clarity you can use, and I'm okay with that.
So, I'm just a bit confused. Aren't they the same thing when you said you could have just done this?
Yeah. Yeah, I'm just saying you could have done it either way, and I would be fine with that for like a quiz.
Wait, so would it have been would it gave you the same result, or would you have to do some extra further steps?
No, it's the same result. So this line of code here with the additional parentheses, it's the same result as this one up here.
Right, because it gave you z equals negative 26.667, and you format it in rationals into z, and z gave you negative 80 over 3.
Yeah, so I was just changing the formatting here. Negative 26.667, that's the same value as negative 80 divided by 3. But I'll go back up here when I had, I didn't have those other two parentheses, and now you see that it's the same answer.
Okay.
So this line of code here, it has two additional parentheses, but it's the same exact answer that we would get with this line here.
Okay, that's a bit weird, but okay, I see.
Yeah, we're just adding parentheses. That's it, just for readability. Okay, so I'm going to clear this out, and we'll move on. So we'll talk about some built-in functions. So this is something that we had in the slides last time, so I moved it down here so we can go over it. So basically, trig functions. That's what we're going to go over now. Of course, MATLAB has, probably thousands and thousands of functions, but we're just going to go over the basics right now. And of course, we don't have time to go over every function in MATLAB. That would take forever. But MATLAB can handle trig functions as you would expect and as you would kind of write it by hand. So we need to be sure that we enclose our arguments in parentheses. So if I want to find the sine of something, I have to type in sine, and then I have to use parentheses. So I could do like sine of 90, and that would work, or I could do sine of pi. And so you'll see here I have a really weird number, right? I'll talk about this in a second, but kind of disregard that right now. Format short G. There we go. So right now I just want you to focus on using trig functions. You can use them in MATLAB, but you need to make sure that you have parentheses. So sine of pi divided by 2, cosine of 0, whatever. We need to use parentheses. Also, by default, MATLAB uses trig functions in radians, so keep that in mind. If you want to solve for something in degrees, you can change that. I'll show you how in just a second. But by default, MATLAB uses radians, so when I have like sine of pi divided by 2, that's in radians. Cosine of 0, that's in radians. If you want to look at more of the other trig functions that MATLAB can do, you can either just type it in and see if MATLAB has that, or you can look at the documentation. And documentation for MATLAB is a big thing that'll help you quite a lot. So, you can either go to Google and type in, trig functions MATLAB. Let's actually do this as a class. Why not? Trig functions. My computer just went really slow. Maybe because of Zoom. Let me stop sharing. Okay, it doesn't like it, I guess. Okay, so I'll go back to MATLAB, but you can just Google trig functions MATLAB. Okay, so let me go back here, and it would show you documentation, so you can do that, but I'll show you what the documentation looks like inside of MATLAB. So if I type in sine, and I put in a left parentheses, MATLAB knows that I'm trying to use the function sine. So this little box will pop up. It'll say sine of x, where x is some argument that we would use. And then we can click on more help here. And then this documentation kind of browser is going to pop up. Well, I just lost it. Let me do it again. Okay, sine. Oh, it's still... Why did it go over here? Sorry, guys. Okay. So here's the documentation browser. So it should show up fine on your screen. Okay, so this is the documentation for sine. So there's actually quite a lot that they show in here. So they're very detailed. So that's good. And then also at the bottom here, they will have this little section that says see also. So there's other trig functions that they have here that you might be interested in. So all of these are stuff that's related to sine. So we have like arcsine and arcsine D, which we'll talk about this D letter in a second. But basically, if you want to look up documentation in MATLAB, that's a good way to do so. Because if you forgot, some arguments for a function or something like that, you can just type in the function in MATLAB and look at the documentation. Okay. So now let's talk about how we can use trig functions in degrees. So remember, by default, MATLAB uses radians for trig functions. So I'll do sine of 2 pi. I'll do a equals sine of pi divided by 2. I'll press enter. And we get an answer of 1. So that's good. That's in radians. Now let's do b equals sine d of pi divided by 2. So if I put in whatever trig function like sine, and right after that I put a d, that d stands for degrees. So now MATLAB will calculate sine of pi divided by 2 in degrees. So now if I press enter, we get a different value than we had up here, because we're calculating sine of pi divided by 2 in degrees. Alright, does that make sense? Okay. And of course, we can use all of the other trig functions as well. So we could do c equals cosine of pi divided by 2. And okay, this is a good time to talk about this. So we have a number here that isn't exactly 0. It's 6.1232 times 10 to the negative 17. So, essentially that's 0, but if you saw this, you would expect it to say 0. It's not 0. Here we go. This is my slide. Because MATLAB uses something called floating arithmetic, which isn't exact. So, if you see this, you should know that really this is a value of 0. But because MATLAB uses this, I guess, computational method of floating arithmetic, it's not going to be exact. So we don't have a value of exactly 0 for cosine of pi divided by 2. Okay, so just know that it's really 0. Alright. Okay, so for this, I guess just put in the chat. If we're going to calculate sine of 90 degrees, and we're doing this in degrees, what should our output be for this code? You can go in MATLAB if you want, or just put in what you'd expect to see in the chat. Okay. Yeah. Yeah, this is from last semester. It's really basic stuff, but yeah, if we go through here, oops, then yeah, we should have a value of 1. If you remember your, what is it? Not a unit circle, right? Why am I blanking on the name right now? What's the name for that? I'm blanking. No one? What's the name for it? The circle in radians that you learned in like trigonometry? No, not trigonometry. Pre-calc.
The unit circle.
Oh, it is called the unit circle. Okay. Some reason that sounded weird to me right now. All right, so yeah, if we calculate sine of 90 in degrees, we should get a value of 1. Okay. Yeah, I don't know. It sounded weird. I don't know. Maybe I was thinking of Mohr circle, which obviously isn't it, but you're gonna learn like Mohr circle later on.
But Patrick, isn't trigonometry same thing as pre-calc?
I mean, yeah, they have some overlapping stuff. Yeah. Okay. Well, actually, yeah, let's do this. I want to make sure that you guys know how to input these trig functions and radians and how to input them in degrees. So I'll give you 1 minute to work on this exercise, just because it should be very fast, and then we'll go over this. So a lot of my lectures, I'll have, a few exercises throughout, just so you guys for sure are using MATLAB on your own. Okay. Alright, let's go over this now. For a lot of the exercises, I'll give you more time than, just 1 minute, but we're doing really simple stuff now, so it'll be fast. Okay, so we have to define x equals 90 degrees and y equals pi divided by 2. So I'm going to do this on one line again. So I'll type in x equals 90, and then I'll do y equals pi divided by 2. Also, remember, the spacing doesn't matter. I could do y equals pi divided by 2 as well. I always like to kind of space things out just to read them better. Alright, so we have x equals 90 and y equals pi divided by 2. You see in the workspace, because of our format, it's in this decimal format here. Okay, so we have to do a equals cosine of x, and a equals cosine of x plus sine of y, where cosine of x is in degrees and sine of y is in radians. So we'll do x equals cosine d, because we want to use cosine in degrees. So remember, that's why we put the d. And then plus sine of y, and because sine of y is in radians by default, MATLAB uses radians, so all I have to do is put in sine of y. If I put in enter, then we get a value of a equals 1. Alright, so that's good. Cosine of 90, that's 0. Sine of pi divided by 2 is 1. Okay. So some other functions that we have in MATLAB, we have the exponential function. So, I don't know if you're typing stuff out, like a lot of times people put e squared, something like that. But in MATLAB, if we want to use the exponential function, we have to type in exp and then put the argument inside of parentheses. So, exp, I don't know, sine of 2 times x. Whatever it is, you want to put your argument inside of parentheses for the exponential function. And then same thing for the natural log. So it's a little weird, but inside of MATLAB, the natural log is log. So you type in log, and we'll say, 2. So this would be the natural log of 2. Log base 10, we have to put log 10, and then whatever we want to find the log base 10 of. Okay, and then inverse trig, basically we just put an a in the beginning. So we put an a before our trigonometric trig function, and it'll calculate that. So if I want to find the inverse sine of something, I put a sine of whatever. And if I want to find the inverse sine of something in degrees, I would put a sine d for degrees, and then whatever I'm trying to solve. Okay, complex numbers. So we'll talk about this for a bit. I'm not going to go, too in depth for this, just because we don't use complex numbers too often, but it's still something that's good to know. So we can enter a complex number 2 different ways inside of MATLAB. So if I want to put in C1 for complex number 1, I can do C1 equals 1 minus 2i. So take note that I didn't do 2 times I. All I did was 2i. So you want to make sure that you don't put a star for a complex number, because if you do that, MATLAB is going to try to multiply 2 times I, which will be the imaginary number. Okay, so that's method 1. And we can also do it by treating or making a complex number with the function complex. Okay, so I'll type in complex and then 1 comma minus 2. Maybe it's not a capital C. If you saw when I typed in complex like this, MATLAB said that it didn't give me any documentation for this. It didn't recognize this function. So make sure when you type in complex, you put a lowercase c. So complex, like that. Okay, so both of these, let's pull them both up again like this. So both of these methods, they give us the same value, so that's 1 minus 2i, but we went about it in a different way. So, to me, this first method seems the cleanest, but it doesn't matter. Either method works fine. Okay, and then let's go back to not putting a star, so basically not multiplying by the imaginary number. So if I want to make the complex number, this will be 3.5. So this will be 0 plus 3.5i. If I want to do that in MATLAB, I'll do 7 divided by 2i. Okay, and this gives us 0 minus 3.5i. If I didn't do that, if I did it like, let's do y equals 7 divided by 2, and I put in the multiplication symbol here, and then I put an I. Remember our precedent stuff from last time. MATLAB is going to see that I have division in here and multiplication. So it's first going to do 7 divided by 2, which will be 3.5, and then it's going to take 3.5 and multiply that by the imaginary number. So because of that, we're going to get, let me press enter, we're going to get 0 plus 3.5i. So just be sure if you're making a complex number inside of MATLAB, you don't use the multiplication symbol with the imaginary number. Okay, I don't even, the only time we use complex numbers, at least in undergrad, would be in your circuits lab and circuits class and in a math class. So, we don't use it too often, but again, it's something that is good to know how to go about it. So I'm going to clear this.
So Patrick, so what are we doing exactly? So like, so we did the example, but like, but like, so, so, I don't know. I'm just a bit lost in terms of after the example, like, well, in terms of what you were trying to explain and show us.
I'm just showing you how to input a complex number. So
Complex number.
yeah, if you want to put in a complex number, when you're putting in the imaginary number, that component, you want to make sure that you just put in I. So like 7 divided by 2i. That'll give you the complex number where the imaginary component is negative 3.5i. If
Oh,
you
got it.
did,
Okay.
yeah, so just make sure that you don't do this multiplication symbol.
Okay. All right. I see. Okay. 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 I see. All right.
Okay. Alright, so we'll go on. So we can do operations with complex numbers as well. So we can do addition and subtraction and multiplication and division. I think that's synthetic division when you have complex numbers. But addition and subtraction with complex numbers is straightforward. So I'm going to again go over this part faster than I will for other stuff that I think is more important. But we'll do x equals 3 plus 2i. And we'll put in y equals 2 minus 4i. And if I want to add x plus y, all I have to do is, I can assign some variable like w and then do x plus y. So really simple, right? Press enter. And our real component is 3 plus 2, that's 5. Our imaginary component is 2i minus 4i, so that'll be negative 2i. So our answer here for x plus y is 5 minus 2i. So pretty simple. We're just doing addition and subtraction. Okay, next thing, subtraction. I'll skip that part because it's the same as addition. It's just subtraction. Okay, so we can multiply complex numbers in MATLAB as well. So what's really happening behind the scenes here is FOIL. So we're distributing using the FOIL method. So let's do s equals 5 minus 9i. You see here I put it in parentheses, but that's not needed. And then we'll do t equals 3 plus 7i. Okay, and then if I wanted to multiply these, so we'll do s times t. I press enter, and then we get an answer of z equals 78 plus 8i. So what was really happening in the background that you didn't see in MATLAB was FOIL. So I actually went out in this slide and showed you what was happening behind the scenes if you don't believe me, right? So we're doing 5 times 3 plus 5 times 7i minus 9i times 3, and then plus negative 9i times 7i. So, now we're just kind of getting into kind of like a straight math class, right? Which we don't need to do here. So I'm just showing you what's going on behind the scenes. Okay, so that's how we get our answer of 78 plus 8i. Okay, so division with complex numbers. Again, I think this is synthetic division. Maybe I'm wrong. It's been a while since I actually did this, like in a math class. But, it's very convenient for us if we want or if we have to do division with complex numbers, we can use MATLAB. Unless you have to show your work. But then you can use MATLAB to check your work. Okay, so let's put this in. So we have u equals 3 plus 2i. And we have v equals 4 minus 3i. And if we want to divide these, we're still going to use the / operator. Because we're still using division, but it's for complex numbers, right? So the / division That's left-hand division. And if you remember from last time, I said left-hand division is to solve a system of linear equations. So that's different than what we're doing right now. So I can still type in z equals u divided by v. Let's do it like that. So our answer then is going to be 0.24 plus 0.68i. If we want to see it in fraction form, sure, let's do this just because I show you what's going on behind the scenes in the next slide again. So I'll do format rational, and then I'll put in z so I can see the output for z. And this is what we have. So behind the scenes, this is what's occurring. So what we were doing was 3 plus 2i divided by 4 minus 3i. I'll make this bigger. Okay, so up top here, this is what we were trying to do inside of MATLAB. And behind the scenes, we had to multiply by the conjugate. So the conjugate here is just 4 plus 3i, and then divided by 4 plus 3i. And then we are multiplying the numerator, and we're multiplying the terms in the denominator. So we're doing FOIL again, and then we're simplifying. So then we get the answer that we have inside of MATLAB. This is the same as we have here. So again, this isn't a math class, so I'm not going to focus on this stuff too much. I'm just showing you MATLAB is doing it correctly, basically. Okay, so any questions on complex numbers? I know I went through that really fast, but again, this isn't the focus of the class, so I don't want to go on this. So go over this too much.
So let me kind of get this straight. So when you were showing us complex and operations, all that stuff, were you trying to when you plug in the PowerPoint example to the MATLAB code, were you trying to show us that that MATLAB gives you the right answer?
Yeah. Because in MATLAB it's very basic. All we have to do is put in the numerator here, put in the denominator, and then we just divide them. And we go, okay, yeah, this is our answer. But here in the slides, I'm showing you a reason to trust that MATLAB is doing it correctly.
Ah, I see.
Okay. Alright, so we are going to have time for arrays. So we'll talk about arrays, and then after this, we're going to go over the length of a vector and the number of elements. So we actually are making pretty good time here, so that's good. Okay, so arrays, a lot of the stuff that we're going to go over now and for the remainder of this chapter, which is, an intro to MATLAB, it's going to be just an intro to it. So arrays, while we're going to go over it now, it has its own chapter, which is chapter 2. And we're also going to go over plotting at the very end for this chapter. That also has its own chapter. So we're going to, have an intro to these right now, but we're going to go into much more depth once we get to those respective chapters later on. Okay, so first off, what is an array? It's just a collection of numbers assigned to a variable. So, not everyone has taken Math 250B in here, I know that, which is differential equations and linear algebra. So when we're in linear algebra, we deal with vectors and matrices a lot of the time. I think, have you guys gone over like vectors and matrices in any other class, like maybe a physics class?
Honestly, vectors, like I know you go through like physics if you're taking physics, and I know like in AutoCAD they professor slightly talks about it, but that's not the main focus. But okay. Yeah, in math, the calculus 3 is heavily influenced by
oh yeah, you do use it there too. Yeah, okay. So I don't think a lot of you have had like a deep dive into vectors, which I think I might have said this before, but it seems a little weird to me that I think a prereq for this class is calc, but not linear algebra, which is kind of weird because a lot of this class is dealing with vectors. So I'm gonna do my best to explain them, But as we continue to use them inside of MATLAB, it'll make a lot more sense as well. So first off though, we're going to start with the definition for an array, which is just a collection of numbers assigned to a variable. So an array can be a vector, or it can be a matrix. So let's first show you a vector. I'm going to show you a row vector specifically. So to define a row vector inside of MATLAB, which again, a vector is a type of array. If I wanted to define a row vector inside of MATLAB, I'll put in my variable. So in this case, I put a lowercase a. I put equals to, and then we're going to have these square brackets. And inside of these square brackets, we're going to put whatever numbers we want to have inside of our vector. So in this case, I'm going to make a row vector. So I'll do, 0, 1, and 2. Okay, so this is going to give us a vector of just 0, 1, and 2. And it's a row vector. So you see here, I only have one row. Right here, there's one row. And I have 3 columns. So here's one column, here's another column, and then here's the third column right here. Okay, so that's how we can define a row vector inside of MATLAB. We also had a question last class if we can use commas, which we can. So I can also define the same row vector by doing 0, and then I can put a comma, and I can put a 1, and I can put a comma, and then a 2. If I press enter, you see that both of these row vectors are the same. Also, let's do it a different way too. I'll do C equals 0, comma, 1, comma, 2. So here I'm using commas again, but I don't have any spaces in between. Again, it doesn't matter. It's going to produce the same row vector. So it's up to you how you want to type them out. If we have a quiz and you have to make a row vector or a column vector, whatever, I'm not going to mark you down, if you put in a comma and I didn't put in a comma. That doesn't matter. Both methods are valid. Okay, and then you can also see in the workspace that we have our 3 row vectors here, and you can tell that they're all the same. Okay, so question on how we clear the workspace. We type in the word clear, and then we can press enter. And then you see that everything just went away. Okay, so let me pull one of these back up. So this is a row vector. Okay, and then we're going to define a column vector now too. Yeah, there's also a button up top. So a lot of the things that we do in MATLAB, you can, sometimes there will be a graphical button up top if you want to clear something or open something up, like Simulink, which we'll get to in the end of this class. You see here it says start Simulink. I can also just type in a command to open Simulink. So a lot of things, if there's a graphical option, you can also type out a command, but whatever you would like to do. Okay, so here we have a row vector. Now let's define a column vector. So column vector, as you would think, and as you can see here, is just a column of numbers. So in this slide here, I have 1 column and I have 4 rows this time. Okay, so let's define this row or column vector inside of MATLAB. I'll type in b equals 3. So whenever we're defining a vector, we have to use square brackets. And inside of those square brackets, we have to put in whatever numbers we want to put in. So here we're defining a column vector, so I'm going to put in 3. That's the first number. Now I need to go on to a whole new row. So to do that in MATLAB, we use a semicolon. So I'll talk about the difference between putting a semicolon inside of these brackets and outside in a second. Just go along with me right now. So we have 3, we put in a semicolon, and now we're on a new row. So we put in 0, then we'll put in a semicolon, put in 4, another semicolon, then we'll put in 7. Okay, if I press enter, then you see that our output is a column vector this time. So semicolons inside of a bracket, that's going to denote, or inside of brackets, like we did here, that denotes going onto a whole new row. When we put a semicolon outside of this bracket, that's going to suppress the output like we talked about earlier. So let's make a new column vector here, like d equals 2, 3, 6, 7, 10. If I want to generate this column vector, but I don't want to see it show up below this line in the command window, I can put a semicolon at the end of this. So this is outside of the brackets. And now when I press enter, I still made this column vector. You can see it in the workspace over here, but the output for it was suppressed, so it doesn't show up in the command window. If I want to see it in the command window, I can type in D and press enter, and then here's our column vector. Okay, any question on making these vectors?
Actually, Patrick, I have a question about the inputs. When you're starting, it gives that blue. It gives that like the blue highlighted thing when you like after you're done putting your input. Like it kind of bothers me. Like is it automatic? Does it automatically put it like that?
I'm not sure what you're talking about. Blue highlighting?
Type in like anything like sign like x equals sign. Yeah. You saw that blue?
No. Oh yeah.
Yeah, it
yeah.
bothers me. How do you like? Does it automatically turn on by itself like that?
Yeah, they're just doing that. See, it's only showing up when I put in that other parentheses. They're doing that to help you, so you know if you matched up all of your parentheses. So like if I have 2 of them and I put in 1, you see it shows up on the inside. Now if I put in the next one, it'll highlight the other one. So that is just showing you that, okay, this parenthesis here matches up with this one over here. So really it's to help you. I'm sure there's a way to turn it off, but I don't know.
Alright.
Yeah. But it is to help you, because if you have mismatched parentheses and you try to run your code, you're going to get an error. So it's to help you out. Okay, so any questions on vectors? Because, you know, this stuff, it is basic, but it's very important for this whole class.
Between those semicolons, can you put commas and more numbers in between?
I don't know why you'd want to put a comma in between. Well, if you're
Like,
making a matrix, yes.
Oh, that's for matrix then, okay.
Yeah, so I don't know if we're going to get to that today. Actually, yeah, it's the next slide. So yeah, we'll talk about that right now. Okay, so I'm going to clear my workspace. Okay, so like they were just saying, we could put commas if we want, kind of in between semicolons. So the only time when we'd want to do that is if we're making a matrix. So basically, we're combining those two methods that we just learned, making a row vector and making a column vector, and we're putting them together. And once we do that, we're going to make a matrix. So, you know, a matrix is going to have a certain amount of rows and a certain amount of columns. So right here, let's define this matrix A. So when we are defining a matrix, by convention, we use a capital letter. Now, this isn't a math class, but I still want to show you what the convention is. So I'm going to put in a capital A. And to make this matrix, again, we have to use square brackets, and we're going to put our numbers inside of them. So how I'm going to first show you is making this matrix by defining the rows first, or kind of building it row by row. So our first row is a 3 and a 0. So I put in a 3 and a 0. And let's just first show you that this is going to be the first row. So I'm going to press enter, and you see that it's a row vector. Let me clear that. So we have 3, 0, and now we want to make a whole new row, so we put in a semicolon. And then I can put 4 and 7. Okay, I'll press enter, and now we have a matrix here. So we have 2 rows and we have 2 columns, so we have a 2 by 2 matrix. And if we want, we can put in commas as well. So I can put in a comma like that. So we have 3, 0. That'll make the first row And we have our semicolons, so we go on a whole new row, and then we put in 4, 7 for the second row. Press enter, then we still have that same matrix. Okay, any questions on that?
Actually, so if you're doing matrix here, does it calculates the answer for you or no?
Well, there's nothing to calculate yet. All we've done is just defined the matrix.
Okay, I see.
Okay, there's a question on how we get both brackets with one click. If it looks like I did it in one click or anything, I actually typed out both of them. So there might be a way to do both, but I don't know how to do that. I know my text editor, I can do that. Like if I put in a left parenthesis sign, it'll automatically put in the right one too, but I'm not sure if MATLAB has that capability. Yeah, I was just doing both of them. Okay, so let's make another matrix here. We'll do, let me clear this. So I'll do B equals 0, 1, 0. So that'll be the first row. And then I'll make a whole new row now. So I'll do 2, 2, 2. That's our second row. And then I'll do another one. 3, 3, 3. I mean, this is arbitrary. And I'll do 4, 4, 4. Okay, if I press enter, then we have our matrix here. And you'll see in our workspace, MATLAB says that this is a 4x3 double. So this means that this is a 4x3 matrix. So again, by convention, and you'll learn this in 250B if you haven't already learned it, but for a matrix, the dimensions of a matrix are kind of denoted by m by n. So the letter m, that denotes the rows, and the letter n denotes the columns. So we have m by n. So in this case, we have 4 rows and we have 3 columns. So this is a 4x3 matrix. So we have 1, 2, 3, 4 rows, and then 1, 2, 3 columns. And that's what MATLAB shows us in the workspace. We have a 4x3 double or a 4x3 matrix. Okay, so we can also define our matrix by columns, and we can build it that way. I'm not going to show you that now. I'll do that later. Just because I just want to show you one way to do it now, and we'll get to making it with columns later. But that's honestly, I usually don't do it that way because it's more messy, because we have to use a lot more semicolons. But you can do it that way if you want. But for now, we're just going to do it the way I showed you here, where we built it row by row. Okay, any questions before we go on here?
Actually, Patrick, I noticed that you didn't put like a column on between 1, 0, 1 and 2, 2, 2, 2 and 3, 3, 3. But for the other matrix, you actually did. Why is that?
Then I put a column?
Not a column, but I forgot.
Oh, I put in commas, right?
Commas.
Yeah.
Yeah. I noticed you didn't do it for the other one. What? Like between 0 and 1 and 2, 2, 2 and 3, 3, 3, so on and so forth.
Yeah, either using a comma or not using a comma. Right here, it's the same thing. It's up to you, whatever is easier for you to read. So I could have put in a comma here and like this. And I know some students prefer that. So if you prefer this, you can do it this way. But me personally, I usually do it like I have up top here. I think this is easier to read, but it's up to you.
Oh, I see. Generally speaking, like not just MATLAB, but like other coding as well. Like, do you wanna? Is it best not to do it? Like, if it gives more work.
I mean, yeah. I mean, I would think so, but if it's easier for you to read, then do it how you want.
All right.
Okay, so we can do arithmetic with arrays as well. So in this example, we're going to add 2 row vectors. So we have a row vector C and we have a row vector D. And we're going to make a whole new variable called E, and we're going to add those 2 row vectors. So I know this isn't a math class again, but just looking at this slide here, you can probably see that you'd expect the output to be a whole new row vector E that has values of 5, 3, 13, and then 7. So I'm just doing 2 plus 3, 0 plus 3, 4 plus 9, and 5 plus 2. And so basically what MATLAB is doing is it's adding each corresponding element for each vector. So, if we look at this again, MATLAB will add the first element in these two vectors. So 2 plus 3, it'll put that value down in our new vector that we're making. And then it'll go to the second element in each vector, and it'll add those. So we have 0 plus 3. Then it'll go to the third element, and it'll add those. That'll be 4 plus 9. And then it'll go to the last one, so 5 plus 2. So I think, and how I lay this out here too, you can kind of visualize it. So I think it's pretty standard to what you would expect. But let's go through this now just to verify that, it's working and just to give you some practice. So we're going to make a row vector C. So we put in 2. Remember, you can use commas if you want. So I guess this time, why not? I'll use a comma. So I'll do 2, 0, 4, and 5. And I'm going to suppress the output here just because I don't want it to clutter up my window. And I'll do D equals 3, 9, 2. Okay, and then if I want to make a new variable called E, where E equals 3 or E equals C plus D, and then I press enter here, then we get a whole new row vector just like we saw on the slide that has values of 5, 3, 13, and 7. Okay, does that make sense?
Yeah.
Okay. All right. And same thing for subtraction, we could do it that way as well. And same thing for a multiplication and division as well. So it'll go element by element here. We're going to talk about operations in more detail once we get to chapter 2, which is for arrays. So, for certain operations, we need to make sure that our arrays have the same amount of elements in each array. But I don't want to get into that right now because that's just adding on, a lot of info at once. So we're going to talk about that once we get to chapter 2. So I'm going to clear all of this out. Alright, so we're going to talk about evenly spaced arrays. So there's going to be actually a lot of times when we want to make an array, or remember, an array can be a vector or a matrix. So there's going to be a lot of times when we want to make an array that is evenly spaced. So this might occur when we have when we're going to make a plot. We want to make our x domain. So let's say we're plotting, I don't know, like something where we have distance versus time. So if we want to make our time domain, which is on the x-axis, if we want to make that from like 0 to 60 seconds with an evenly spaced interval, we can do that inside of MATLAB on just one line of code, and it's very simple to do. So here's the syntax where we have some variable, and we're going to set this equal to the first value that we want. Then we're going to use a colon, and we're going to put the step size that we want. And then we'll put another colon and then put the last value that we want. So let's do an example here. So let's pretend that we're going to make a variable called x, and I want to make this vector, because it's going to be a vector. I want this to go from 1 to 10 with an evenly spaced interval of 1. So this evenly spaced interval, that's also called the step size. So that's the interval that we have for each number. So we're going from 1 to 2 to 3 to 4, and then so on. So I actually, I didn't catch this before. This should be a 1 right here. So because I wrote out zeros down here, let's pretend we're going to make a variable for x from 0 to 10 with a step size of 1. So I'm going to put a 0. That's the first number that we want. Then we put in a colon. Then I'm going to put in 1. Remember, that's going to be the step size that we have. I'll put in another colon, and then I'll put in 10. So 10, that's going to be the last value that we have. Because I'm going to press enter now. You see here, it looks kind of like nasty, but it's telling us right here that we have a row vector. It says columns 1 through 5, because this is all MATLAB could fit on my screen. So on your screen, it might say something different. It might say like columns 1 through, I don't know, 3 or 4. But it's going to go all the way to 10. So you should see something that's similar to what I have here. And this is also why I often will put a semicolon at the end, because, you know, this is taking up almost half of my command window here. It would be easier if I just did this. So I have my row vector that I'm creating here, and I'm going to put a semicolon at the end so I don't see all of that show up in my command window. But if I want to look at this output, I can go to the workspace, and I can double click on X, and then it'll show up here, and it looks, you know, way nicer in here than it looked like in our command window. So we see the size here, it says 1 by 11, so we have 1 row and 11 columns. Okay, so we made a row vector, and you can also see that our step size here, it is 1. You know, we go from 0 to 1 to 2 to 3, and so on. And if I scroll on the bottom here, we see that the last value is 10. Okay, so let's do a different row vector here. Let's do y equals 0, 2 to 10. So this time when I create this new variable or new row vector y, we're going to start from 0, and this time we're going to have a step size of 2. So we're going to go 0, 2, 4, 6, 8, 10. So if I press enter, and let's actually type in y here. This should look better. Okay, no it doesn't. I thought it would display it a little differently. If my font size was smaller, it would look better. It could put it all in one line, but my font size is too big. So let's go to the workspace, and you can actually see it here, right? This new row vector that I made was small enough that we could display the entire row vector in the workspace. The one up top here is too long. If I like take this out, let's clear this, and then let's go back here. No, it's still too long. Okay. Doesn't matter. Let's go back here. So let's check out y now. So I'm going to double click on y. And then you see here that we have a row vector from 0 to 2 to 4 to 6 to 8 to 10. Okay, so we have a step size of 2. Okay, does this generation make sense to everyone? Yeah, okay, that's good. So I'll just say it one more time if anyone is a little confused though. The syntax, the very first thing that we have is the first value that we want. Then we put a colon, then we put the step size that we want to have. Put another colon, then we put the last value that we want to have. Okay, so this will be something that, again, we use pretty often actually in this class. So there's also another way that we can generate vectors, which will be using the linspace command. So I'm just going to mention this now, because we'll go over this later on too. But this is going to be another way where we can generate row vectors that are quite large if need be. But that'll be in, I think, chapter 2. So we have a few more minutes, so we have a little time to go over this. So we're going to go over the length of a vector. Okay, so for a one-dimensional vector, so that means either a row vector or a column vector, the length of a vector is going to be the number of elements in that vector. So let's look at our row vector y here. If I look at the workspace, I see that we have 6 numbers in here. We have 1, 2, 3, 4, 5, 6. So we have 6 numbers, or 6 elements really, inside of our row vector. So sometimes when we're writing a script or something, we'll want to know how many elements are in a row vector or a column vector. So to do that, we can use the length command. So I'll type in a length here. And then I'll put in y, because I want to look at the row vector y. So I'll press enter, and then MATLAB will give us an answer of 6, because we have 6 numbers within that row vector. Okay, and then for x, if we do that, if I do a length of x, that'll be an answer of 10 because we have 10 elements in that row vector. There's also another command that we can use, which I guess is in another slide, but I'll talk about it now, which is numel. So basically a number of elements. So if I type in numel of y, that gives us the same answer that we had for the length of y. Same thing for x. If I do numel of x, we're going to get the same answer. So why would you want to use length versus numel? Well, for like a vector, a one-dimensional vector, it doesn't matter. So you can either use length or numel. Technically, you can use either or. I think numel is actually a little bit faster than length, especially if you start to get a really large vector, then it would be faster to use numel because it doesn't care about the type of data that's within your vector. So that'll be faster, but really for what we're doing in this class, it's negligible. So you can use either or in this case. But the benefits of numel, or the differences for numel and the length command or function, that becomes more apparent when we make multi-dimensional arrays or, a matrix. So let's see the differences in the last few minutes here, and I'll go over this part again next class too. So if I make this matrix that we see in the slide, so 3, 2, that's the first row, 2 and 4, that's the second row, and 6, 9, that's the third row. And this is our matrix. If I do numel of A, we get an answer of 6 because we have 6 elements in here. We have 1, 2, 3, 4, 5, 6. If I do length,
Patrick, quick question. Explain what numel means again.
Numel stands for number of elements.
Oh, number of elements. Okay.
So now if I type in length of A, now I get an answer of 3. So this is different now, right? This is, if we have a multi-dimensional array, like a matrix, and we use the length command, in this case it's not giving us the total number of elements in this matrix, but it's rather giving us the number of elements for the maximum kind of dimension here. So we have 3 rows, and that's more than 2 columns, so MATLAB gives us an answer of 3. So that difference is something that you got to keep in mind. But again, we're going to go over this again. I'll restate it next class, so it's going to be a little more concrete. Okay, so that's all we have time for. So there was a good amount today, I think. But if you guys have questions, you can stick around after the class or go to office hours tomorrow at 12 p.m. I think it's 12 p.m. I got to double check. Let me check.
It's
really
12
quick.
tomorrow.
Okay. I don't know if I made it 12 or 1. So from 12 to 1. Alright, so I'll see you guys on Wednesday.
Patrick,
Thank you, Professor.
I have a